reviewing the properties of exponents, and we just talked about how an exponent is a shortcut way of writing repeated multiplication. So x to the third is the same as x times x times x. Now, if we use that idea and we take x to the fourth times x squared, well, x to the fourth really means x times x times x times x times x squared. Well, x squared means x times x. How many x's do we have in this repeated multiplication? 6 of them. Do you see that the shortcut for this is to take this exponent and add it with this exponent to give us this exponent? So, when we are multiplying like bases, we add the exponents. When you multiply like bases, you add the exponents. Alright, so if we had 2 to the third times 2 to the fourth, well, I have like bases. Both of the bases are the same. They're 2. So that is the same as 2 to the 7th. Now, we could simplify that, but let's leave it in exponential form right now. Okay? So it works when our base is a number. It also works when our base is a variable. So if we had n to the 5th times n to the 11th, when we multiply like bases, we would add those exponents and it would become n to the 16th. Okay, here we have xy to the 4th times x squared y to the 3rd. Well, we do have some like bases here. We have x's and we have y's. So here I have an understood x to the 1st, and here I have an x squared. So when I add those exponents, it becomes x to the 3rd. And here we have y to the 4th and y cubed, so that becomes y to the 7th. All right, now the 3 and the 2, they're not the same. But here we have a squared and an a to the 4th, so that becomes a to the 6th. And so we would have b to what power? B to the 3rd, because the understood 1 plus the 2 makes 3. And c to what power? 4. The 4. Now, here we have the 2 and the 3. What do we do with that now? We actually just multiply them. So 3 times 2 is 6. So simplified, this becomes 6. A to the 6th, b to the 3rd, c to the 4th. Any questions about multiplying like bases? Multiply like bases, what do you do with the exponents? Add them. Okay, so now here we have dividing like bases. And I actually want to change this a little bit. I'm going to change this problem to where it's 5. There we go. Okay, so I'm going to show you the expanded form again. X to the 5th is really x times itself 5 times. And x squared is x times itself twice. So when we look at the expanded form, we can see that this x can cancel with that one. This x can cancel with that one. And how many x's are left? 3. All right, so what is the shortcut that's happening here? When we divide like bases, what are we doing with those exponents? We are subtracting. Now, I think of it two ways. Sometimes I think of it as subtraction, and then sometimes I think of it as canceling. So if I were to think of it as canceling, I would say, all right, these two x's cancel with two of these and leave me 3. And you can think of it either way. So here we have division. So if I thought of it as subtraction, I have the like bases, so I can do 13 minus the 5. So what does that leave me with? 8. Okay, or if I thought of it as canceling, these 5 ends cancel with 5 of these and leave me 8. Either way, same thing. Yes, sir.
What if there was the same amount of exponents on both sides of the
So you're saying like if I had x to the 6 over x to the 6? Okay. We could think of this as 6 minus 6 is 0, and we're going to get to this. Anything to the 0 power is 1. Or we could say anytime we divide anything by itself, it's 1. Okay. Yeah, I like it. Okay, so let's do the subtraction here. This a in the denominator is to the understood first power. So when we do the subtraction, we're doing 2 minus 1. And then we have 5 minus 3. So this simplifies to a times b squared. Okay, so, or we could say canceling. This one cancels with 1 of those and leaves 1. 3 of these cancel with 3 of those and leave 2. So we're left with an a to the first b squared. Same thing. Now, if we thought of this one as subtraction, it's kind of jumping the gun a little bit because I hadn't talked about negative exponents. But what is it? 2 minus 8? Negative 6. Now, we generally wouldn't leave our answer with a negative exponent. In simplified form, we wouldn't. Now, you may or may not remember that that negative exponent is actually going to move it to the denominator. The negative exponent moves it to the denominator. So if we did this one like canceling, 2 of these cancel with 2 of those, do you see how it kind of takes us straight to the answer? Now when everything cancels out, it leaves the understood 1. Good. Alright, so we've done multiplying like the basis, we've done dividing like basis. Now let's look at a power raised to a power. A power raised to a power. So if we wrote this out, it'd be 2 squared times 2 squared times 2 squared, because it's being cubed. And 2 plus 2 plus 2 is 6. So what happened to the exponents? They got multiplied. So when you raise a power to a power, you multiply the exponents.
You what? Multiply it?
Mm-hmm.
What are these called? Powers?
A power to a power, yes sir. Powers.
Exactly how I started off class when I started taking notes. And then it stopped.
Okay, now this is kind of jumping a step because I didn't give us one that's just something raised to a power. This is actually a product raised to a power. And when we raise a product to a power, everything in that set of parentheses has to be raised to that power. So right now the 2 is raised to the understood first power. So what is 1 times 3?
Wait.
1 times 3 is 2.
Yeah.
Okay,
Hmm? Everything in here has to be cubed. So this 2 is raised to an understood first power, so 1 times 3 makes it 2 to the third. Yeah, we're going to simplify that in just a second. And then the 2 is squared, but it's raised to the third, so it becomes 2 to the 6, x to the 6. The y is to the first power, so 1 times 3 is 3. And the z is to the fourth, so 4 times 3 is 12. And you guys were all right. You didn't want to write it as 2 to the third, and I wouldn't want you to. What is 2 to the third? 8. So when we completely simplify this, it's 8 x to the 6, y to the third, z to the 12.
That's the final answer?
Mhm.
Oh yeah, because you gotta do.
Mm-hmm.
Yeah, 2 times 3 was 4. And you times that by
Can
2.
you just start off with
You sure could. Yeah. Yeah, I put a little thing through. Because they look just like my tooth sometimes. Okay, now these problems can have all of this stuff mixed up. We could have the multiplying, the dividing, and the powers all within the same problem. So you have to follow PEMDAS, your order of operations.
Yeah.
You want to deal with those powers, simplify what's inside the parentheses, then deal with your powers, and work your way out. So there are lots of correct ways to work these problems, but there's only one right answer. So we can all get to the one right answer a little bit differently, the more complicated the problems become. And so we're going to have some on our homework that get a little more complicated, and then we'll look at some more tomorrow. Okay, so we've already talked about negative exponents. We said the negative exponents have to move. So if we have x to the negative second, it becomes 1 over x squared. But what if we had a whole fraction raised to a negative exponent? What happens to the whole fraction? The entire fraction will be flipped. So if all of this is raised to a negative exponent, all of this must flip. Okay, so this kind of combines a couple things. First, we dealt with the negative exponent by flipping the entire fraction. Now, this entire fraction has to be raised to this power. So, the b squared gets squared and becomes b to the fourth. The 4 gets squared and becomes 16. And the a also is squared. And that's the simplified answer. Okay, so if we just have a term raised to a negative exponent, it becomes the fraction. If we have a fraction raised to a negative exponent, everything gets flipped. Now, what else could happen? We could have negative exponents within a fraction. And when we have negative exponents within a fraction, the only thing that moves
Oh, no.
is here and here.
No, not yet. Give us a chance. Give us a chance.
Okay. So this kind has negative exponents within the fraction. And that is the only thing that moves. This moves down. This moves up. So the 3 and the a squared do not have negative exponents. They don't move. The c moves up and the b moves down. And when it moves, the negative exponent goes away. Okay, and the last thing I wanted to remind you of is when we have anything raised to the 0 power. I can't really say anything because 0 to the 0 is not defined. So anything that is non-zero raised to the 0 power is 1. So if I had 3 to the 0, that is 1. If I had negative 50 to the 0, that is 1. If I had 4a squared b to the 0, that is 1. Okay? Now, the other side of the worksheet. You took notes on the front. The back is your homework. I want you to go ahead and get started with that. And I want you to do it for understanding, not for completion.
Ma'am,
Yeah.
are your notes in that?